Hello guys, welcome back to Dawn Academy. Today, I'm going to be teaching you a little bit about equilibrium. Okay, so we're going to start off with this problem, and I'm expecting you to have some previous context about equilibrium. Well, if not, it depends on some things like pressure, temperature, and volume, and a catalyst. But those are like conceptual things that you should definitely review if you don't know what they are. And we're going to be applying those in some problems where we're asked to find Kc. So our scenario is that this kid is going to put some PCl3 and some Cl2 in a flask, and it's going to be at 350 degrees Celsius to produce PCl5. At equilibrium, this amount is found, and they're asking us to find Kc. So when they ask us to find Kc, it means we need to find the concentration of reactants and products at equilibrium. Reactants and products at equilibrium. So to do this, we're going to use our little ice chart. Let's zoom in a little. Okay, so ice. Initial change and equilibrium. Initial change, equilibrium. We're basically just filling out this chart, and that's going to help us find the Kc of our reaction. So we're going to start out with writing the formula. So we know that we're going to have PCl3 in gas, plus we're going to add some chlorine to it, also in gas, to produce PCl5, also in gas. And this seems pretty balanced. We don't need to change anything out here. Everything looks pretty good. Okay, now let's go back to our given. So our given tells us that we have 0.20 moles of PCl3. So we're going to write that down. But we need to remember something first. Everything in this chart has to be in concentrations. We don't want to have it in moles, but conveniently, our volume is 1. So we're going to wind up with the same thing in moles and in concentration. So we're putting this in concentration right here. So we have 0.20 moles per decimeter cubed of PCl3. We have 0.1 moles per decimeter cube of Cl, and we don't know how much of this we have, so we're going to put it as 0. Change is when we're looking to see if the products are being formed or if the reactants are being formed. So we know that we're starting with 0 product whatsoever. So I'm going to say that we're going to be losing reactants to form products. And we have to adjust this based on our equation. So over here we have no coefficients. If we did have a coefficient, let's say we had a 2 here, this would be 2. If this was a 3, we would have a 3. So change depends on the moles of our reactants. Match them to the change. Okay, so we know this is going to be adding because we're making products and we're losing reactants, which is why it's minus. And yeah. Okay, moving on. At equilibrium, we have another piece of information over here. We have 0.12 moles of PCl3 at equilibrium. So we actually can see that the reactants decreased. So we have 0.12 moles, which is going to be moles per decimeter cubed. And yeah, here it's going to be 0.1 minus x. Here it's going to be 0 plus x, which is just going to be x. And from here, we know this is supposed to be 0.20 minus x. So from here, we're able to figure out x very conveniently, actually. Our little equation is going to be 0.20 minus x equals 0.12. If we just do that really quickly, 0.2 minus 0.12 is 0.08, which is x. Now, we're going to be able to substitute that into the rest of the equations. So now let's find the concentration. So we know the concentration of PCl3 at equilibrium is going to be 0.12 mole per decimeter cubed. Now we need to find chlorine, which is going to be 0.1 minus x, which is going to be 0.1 minus 0.08. It's going to be 0.1 minus 0.08. It's going to be 0.02 moles per decimeter cubed. Now we're going to have PCl5, which we can also take from over here. It's just going to be x, so it's going to be 0.08 moles per decimeters cubed. Oh, that's not a cubed. Cubed. Next, we're going to have to draw our Kc equation. So let's go back to our equation over here and find Kc. So we're going to put our products on top and reactants on the bottom. So we're going to have concentration of PCl3 times the concentration of Cl2 over... Oh, I made a mistake there. Did you notice? I put them on the wrong side. Reactants are on the bottom, my bad. And PCl5 up here. Now all we need to do is substitute with the values that we got down here. So our concentration of PCl5 was 0.08. So 0.08 up here over 0.02 times 0.12. Now if you do the math, we get 0.02 times 0.12. We're going to get 0.0024 and 0.08 divided by that. So 0.08 divided by 0.0024, we're going to get 33.3. And that is going to be our final answer. This is the value of Kc. And yeah. Thanks for watching. And I hope that was useful for you. Oh, I made one more mistake. It's just supposed to be 33. Sig figs. Thanks for watching, and I hope you learned something. If you have any questions, do let me know. Bye.